Type of formulas. There are three types of formula: empirical, molecular, and structural. Now, the empirical formula of a compound shows the relative number of atoms of each element present using the smallest whole number. So we're talking about here is the smallest whole number ratio. For example, the empirical formula of hydrogen peroxide is HO, which is a 1-to-1 relationship between hydrogen and oxygen. The molecular formula of a compound gives the actual number of atoms of each element in a molecule. So the actual formula of hydrogen peroxide is actually H2O2, where that is a 2-to-2 relationship, where there's 2 hydrogen for every 2 atoms of oxygen in each molecule. Let's take a look at 2 examples. In the first compound, we have H2O. That is a 2-to-1 relationship. Since you cannot further factor this by common factor, this would tell you that this is a empirical formula. In the second example, we have a relationship of 4-to-2. Both numbers can be factored further down by 2, resulting in a 2-to-1 relationship. So this tells us that this is a molecular formula. So what is similar and different between empirical and molecular formula? What is similar is that both the empirical and molecular formula share the same elements. What is different is that both of them have different subscript associated with the elements, so the subscript change. Now, structural formula is a formula that shows the number of each type of atom as well as their physical arrangement. So let's take a look at this example. This is H2O. This shows you how the atoms of hydrogen and oxygen are actually physically arranged. Let's take a look at these 3 compounds. In the first compound, you see that there is a 2-to-2-to-2-to-2 relationship, and all of these numbers have a common factor of 2. So that means that they can be further reduced. So this tells us that this is a molecular formula. In the second example, we see that this relationship is a 1-to-4 relationship. Since this cannot be further reduced by a common factor, this tells us that this is an empirical formula. And finally, in this example, this is a physical arrangement. So that should tell us that this is a structural formula. So how do we convert from molecular formula to empirical formula? Let's take a look at these 3 steps. First, you identify if there is a common factor. Then divide all the subscript by that common factor and then write the empirical formula. So let's take a look at this formula. First, we're going to identify the ratio. So this is a 6-to-6 relationship. Both of these can be further divided by a common factor, which is 6, and that will reduce it down to 1-to-1. And so now the new formula is C1H1. And since we cannot write the formula as C1H1 because we don't write the 1 next to it, the actual empirical formula for this is CH. And that is the empirical formula for the molecular formula C6H6. So let's do some further practice. In the first example, we have 4P210O. This can be further reduced by the number 2, which will give us 2, 5. Okay, so therefore, the new formula for this is P2O5. In the second example, we have a 2 to 1 relationship. This cannot be further reduced. So therefore, the empirical formula is the same thing as the molecular formula. In the last example, we have a 5 to 12 to 1 relationship. There is no common factor that will further reduce this ratio down. So therefore, the molecular formula and the empirical formula are the same. So what if we are given the structure formula? We can write the molecular formula, and from there we can write the empirical formula. So what we do is we identify each element in the structure formula. Then we identify the amount for each element, and then we write the amount as subscript next to the element. So in this case, we have a structure formula. So first we can identify the elements. So we have C, H, Br, and Cl. Then we're going to count. So we have 1, 2, 3, 3C. And we have 1, 2, 3, 4, 5, 6, 6H. We have 1 Br. And we have 1 Cl. And as we discussed before, we do not write the number 1. So when we rewrite this, it will be C, 3, H, 6, Br, Cl. So this is our final answer. In this example, we will first write down the element. So we have C, we have H, and we have Cl. We see that we have 1C, 2C, 3C. So that is 3C. We see that we have 3H over here, 3H over there, that makes it 6, and then another one up there, that makes it 7. So that is 7H. And we only have 1 Cl. Okay, so let's rewrite that, and that becomes C3H7Cl. And that is our molecular formula. So let's look at this example. In this example, we have C, we have H. Let's count the number. How many C's there is? There's 1, 2, 3, 4. So that's 4C. And the H, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is 10H. So that is the molecular formula. But note that 4 and 10 has a common factor and can be reduced down to 2 and 5. So therefore, as a result, our final answer is actually C2H5. And this is our empirical formula, while this is our molecular formula. Let's do one more. So we have N and H. And we have 2 N's and 4H. So that's 2N and 4H. This is what we call our molecular formula. Now, can this be further reduced? Yes, it can. It can be reduced by a common factor of 2. Okay? And when we further reduced it down, we now have NH2. And this is our empirical formula.